when you're setting up your design, you should always be thinking about, what am I gonna count? What am I gonna count? What am I gonna count? I can't get a comparison without something to compare. What am I gonna count in order to compare it? And here's the questions here. So, actually, somebody told me this years ago. I was having trouble with a house in Amsterdam full of fleas. I said, well, you know what you do? You get like a desk lamp and you go and you get a green bulb. Just, it doesn't have to be special, just gotta be green. And you put it in the desk lamp and you put it on the floor underneath a shallow tray of soapy water. And the fleas are attracted to the green light, they jump at the green light, they fall in the water, and they drown. Okay. Now you could test that, right? You could set up, the green light and soapy water. What's the variable? Well, the problem there is the variable's the whole apparatus, right? If we set it up and it did nicely, then we're looking at it going, does it matter if the light's green? Does it matter if the water's soapy? Does the light have to be really close to the floor? There's so many things in that setup that you don't really know what it was that was important and what it was that wasn't important. So, but we could do just a light. We could do, just, the whole thing and no soap in the water. We could kind of back up and take out some of the parameters, but we'd have to run a bunch of tests. Here's another thing you run into. So we do this, and we get a bunch of fleas in the water. So I went home, I didn't actually go home, but say I went home and I did that, and I got a bunch of fleas in the water. What one thing did I have to know about the situation that I don't know? I don't know how many fleas are in the room. It could be, if I just set the water out, that it would fill up with fleas, because there's so many doggone fleas hopping around the room that they would invariably, some of them would hop into the water. So this one isn't a good field test. This one is a good lab test, where you can set up an enclosure, put a known number of fleas into the enclosure, and then run your test and your comparison tests at opposite ends of your enclosure. And then, what are we counting, fleas? We could count fleas, right? What's better than soapy water if we're gonna, at the very end, count fleas? Do we know they'll drown in the water? We really don't. We want something that's a little bit more certain. If their fleas are attracted to this light, we want to put something under the light that's really gonna not let them go. And they actually have sticky pads for that. Little white rectangular sticky pads. And so we could set our light up with a sticky pad under it. We could set a light up over there, but don't turn it on, right? You want this as comparable as possible. And so that would test the attractiveness of the light itself. We could vary the colors on other tests and see if the color matters. We could just put the pans out and see if they'll jump into the pans without any light there. We could put soap in the water, no soap in the water. But we would need to run a whole bunch of tests to figure out what's going on. If we got the water though, we somehow need to watch the fleas hit the water in order to count whether the fleas are attracted to the water. And that's a much trickier experiment. And that's happened sometimes. It's like right now, there's all this debate over whether having had COVID makes you immune for a lengthy period of time. And they found when they test people's antibody levels, they tend to drop after a couple of months, which is pretty much what happens whenever you have a disease. But it's an easy measure. Is that the people in the vaccine business are going, that isn't what you measure. That isn't a good measurement for what you're looking for. You need to measure these cells and these cells and these cells. And so it turns out to be important what you count and how you count it. So you're standing at the gas pump putting premium gas into your car and somebody across the way goes, that car doesn't need premium gas. And you go, no, but it runs better. No, it doesn't. You go, yeah, it does. You go, no, it doesn't, you know, if it's rated for regular gas, putting premium gas isn't gonna make it run better. Now, that's a hypothesis, right? You can test that hypothesis. What's the variable? It's a pretty obvious variable. Somebody's gotta know the variable. Yeah, so it's the two different grades of gasoline. The tricky part here is, so it runs better. What the heck is that gonna mean? What are we gonna measure to compare cars? If we're gonna run this test, we need a lot of cars. We need to be all the same make and model. And then we need to run the test, and then we're gonna measure something. But then the question is, what are we gonna measure? If you had to do it, what would you measure? Everybody in here could figure out your mileage, right? Is that a measurement of how well your car's running though? It kind of comes back to the antibody thing. Mileage is an easy measurement, but it may not really be measuring what you need to measure. And here's another issue you wind up with in science. You may want to do the test, but you go, I don't really know enough about cars to come up with a valid measurement for this. I need to check with somebody, and that's what you wind up doing. Sometimes you use an expert to do your measurements for you, and you basically say to them, okay, I need you to explain to me why this is a good measurement, but I need you to do the actual measurement because I don't know how to do it. And that's not a weakness in a test, as long as you can explain it all. And it happens a lot, where you kind of, sometimes you send stuff off to be tested. And as long as you can explain to people, okay, this is why we tested this is what the guy told me, and they go, well, I don't know that he was right about that. Well, he's my expert. I'm stuck with it. Remember years ago when I used to be a judge at the actual state level for high school science projects. And at the very top level, you get some very, very complex stuff that people have done. And so I'm on the panel and I say to the students, so this data manipulation you did to get these numbers, how did you do that? And she goes, well, I don't completely understand it. I can tell you what I was told, but I actually went to a statistics professor and he told me how to do this, and he ran the numbers for me. You could tell on her face, she's thinking, oh crap, I'm in a lot of trouble for this. But it was exactly what she should have done. She didn't have the expertise to do exactly the data manipulation she needed. She found somebody who could. Not a big deal. So, we're testing a headache remedy. How are we measuring the headache?
Scale 0 to 10.
Okay. 0 to 10 sound good? Obviously, there's a trick here, because it's coming up again. Here's a problem with 0 to 10 that a lot of times people don't realize until well into the study. So we've been running the study for a couple of weeks now. We got our 167th person in with their headache. And we go from 0 to 10, how bad is your headache? And they look across the table at you and go, what's a 10? Is it the worst headache a person could have? Is it the worst headache I've ever had? Is it the worst headache I can imagine a person having? Those are pretty different 10s. And you don't realize without defining the top of the scale that the top of the scale has been different in everybody's head because they've been defining it for themselves. So the 0 you don't really need to define, but you do need to define the top limit of your scale. Because I think if I were doing it, I'd go, okay, a 10 is the worst headache you've ever had. When somebody else would go, I don't know that that's, because that varies so much from person to person, maybe it's they should be the worst headache that they think a person could have. And those are, okay, as long as you are clear with this is the way I define the scale, this is the way they define the scale. But you do need to make sure that top of the scale gets defined as well. So we'll see what you can remember 10 minutes later. We did the pillowcase thing. We tested a certain fraction of our tests with the same fabric on each side. And a certain fraction of those people picked something anyway when we knew there was no choice. What were we supposed to do with that data? If 12% of that group gave us a choice, what do we do with that 12%? See, this is why you don't want to design it into your experiment. You got to go to the people that pick yours and drop it by 12%. You go to the people that pick the other one and drop it by 12%. Turns out you can't trust, you just decided 12% of everybody is telling you something that's probably not true. So we got to reduce every group by the percentage we got in our no choice group. And of course, if you're getting good numbers for your particular pillowcase preference, you don't really want to drop those numbers, and this is why it's often not done. In a related thing, if you're ever asked to do an extensive survey, lots and lots of questions about stuff, about 3/4 of the way in, especially on a written survey, you will probably get a question and you'll look at it and go, how does anybody not answer this way? It'll be something really, they'll give you 3 choices or 4 choices, and 3 of them are really terrible. Nobody in their right mind would pick them. And you go, why? That is to catch people who got halfway through the test and just started marking stuff because they got bored and tired, and they wanted to finish the test because they knew they were supposed to finish the test, but they stopped reading the questions. And they will make choices on that question that nobody would make. And it's like the people that give you a choice when you don't give them a choice. Is that it's a way to factor in how many people you could really rely to have gotten to the test and are really answering the questions. But I've seen that happen on survey. So you are known as the scientific fisherman, or fisher person, or fisher woman, whatever they're fishing. Somebody hires you for, it's like a New York vacation magazine. They say, we're gonna give you the money to go out over the course of the summer to 10 different lakes in the Adirondacks. And we want you to measure a bunch of things about each lake, rate them. A bunch of things. We'll let you decide what you're gonna measure, what you're gonna rate. And we just want you to come up with a clear explanation of what it was that you were measuring. And we're gonna put that in our magazine. And we're gonna use that to determine which are better lakes for fishing. So somebody give me something that you're gonna go out and measure. What's gonna vary between these lakes?
The types of fish you catch?
Okay, types of fish. And for that, I probably am gonna come up with this is a better fish, this is not so good a fish, this is not so good a fish, this is not so good a fish. And say, this is what I was pulling out of the lakes, what people told me they were getting out of the lakes, and here's my rating based on and basically I'm saying, I like this fish and this fish and this fish. Whereas somebody else may be reading it, well, I kinda like the fish you got 6th on your list. But I see your measurement there, I'm going to that lake and fishing for suckers. So, even though I don't agree with your measurement is clear enough that I can use it for my purposes. Because what you think is good is maybe not what I think is good. But as long as you're clear in how you measure it, that would work. What else can be different between these lakes? Yeah, you could give the pH of the water. You'd have to explain what that means in terms of the fish. And usually it doesn't mean much unless there's a huge variation. And actually the pH in Adirondack waters is actually pretty stable now that acid rain has dropped off, where actually the logging has gotten a lot reduced. The logging had a much bigger effect on the pH than the acid rain did. But yeah, you could do something, straight up measurement and explain that. What else could you measure? Well, you said temperature, right? How the lake,
Like clear condition.
okay, but I need something, okay, what does condition mean? Give me something I can measure. Because you say condition, and I'm thinking like 10 different things in my head. Because you're absolutely right, but you've got to break it down to this part of the condition, that part of the condition, you know. How clear is the water is a condition?
How clean is the air?
How clean the environment is, you know. Are there a lot of houses around the lake? Now, is that a good thing or a bad thing? If a lake has got a bunch of people living around it, is that a good thing or a bad thing? You may think it's a bad thing, somebody who reads your article may think it's a good thing. There may be a bunch of people out there fishing. Some people may think that's horrible. I hate being in a place where there's a bunch of other people. Other people may go, oh, I love fishing. It's kind of a social thing. I get to talk to the other guys. I want to go someplace where there's a lot of people. But that's the thing, is that a lot of stuff you would measure may mean good to you and bad to somebody else. But as long as it's clear how you're measuring it, like if you like a lake with a lot of people on it, then I'm gonna go for your low-rated lakes. I'm not gonna go for your high-rated lakes, because I wanna go someplace where there's nobody. You know, you can measure things like accessibility. You can measure, well, here's the point. If I gave you this as an assignment, come up with 10 different things you could measure and compare from one lake to another as amounting to quality, you would all give me different lists. And so when people design experiments, what they measure turns out to be really important, and it isn't always what somebody else would measure. A lot of times you'll hear, okay, I thought they said this was bad for you, now they're saying it's good for you. And you're going, yeah, if you look at those studies, they weren't looking at the same thing. A number of years ago, this was a big deal, is that they talked about putting people on a low sodium diet after they'd had a heart attack. One study comes out, another study comes out. First study comes out, said that the people on the low sodium diets compared to the control people had fewer heart attacks. Oh, that seems good. The other study comes out and says, we compared the mortality rates over the next 10 years for these people, and they were the same. Is that the people in the study group didn't die of heart attacks as often, but they died just as often as the people in the other group. And you go, well, that's weird. But that was the result they got. And it seemed conflicting, but they were measuring two different things. So you're watching the news anytime in the last few weeks. And somebody's, you know, man, they should get control over these guns. These guns are really dangerous. Because I think it's a really bad idea for people having these guns in their houses. And you go, I don't know what you're talking about. Guns are not dangerous in a house. You go, yes, they are. You go, well, okay, well, show me. We're gonna test the safety of having guns in a house. What are we gonna measure? What are we gonna count? Somebody?
The factor of time around the home or within the home?
Hmm?
The factor of time that occurred at the home or around the home?
That one becomes a bit iffy because it kind of assumes that criminals are psychic. How do they know whether there's a gun in your house or not? So, and why would crime in your neighborhood necessarily be affected by whether you've got a gun in the closet or not? So I don't know that that is a good measurement of that. Is that, now you're right, what you just gave me is a confounding factor. You would expect to find more gun ownership in houses in high crime areas, right? So if you're gonna compare houses with guns to houses without guns, if you've got 3 houses in a high crime area with guns, you gotta find 3 houses in a high crime area without guns. That's your comparison group, right? Because you're right, that's definitely a factor. But it's more of a factor kind of impacting whatever else you're gonna measure. So what are we gonna measure? You guys are not gonna fall into the trap, are you? At least by not giving me, many answers, you don't fall into the trap. Can we compare gun injuries? How many of those are gonna happen in a house with no guns? That's often the trap that people fall into. How many times are people hurt with guns? Well, that's not gonna happen in a house with no guns, or it's not gonna happen very often. So you can't pick something that specifically focuses on guns to count. So back up a little bit. You said, how many gun injuries? Okay, back up. How about injuries? And then you just have to define what amounts to an injury. You stub your toe, is that an injury? No. Well, why not? Well, it's not a serious, okay, well, how serious does it have to be? Okay, we'll define an injury as something that requires medical attention. Okay, just going to your family doctor, okay? Yeah, that's okay. We can compare that, right? That can happen in both groups of houses, injuries that rise to medical attention. And we could use that. Some people would want to say, reports of domestic abuse. I'm not sure that that's a great comparison, but if you make it clear why you think that that's worth comparing between gun houses and no gun houses, you could do that. Other confounding factors other than crime is how many people are in the house, what kind of people are in the house. People go, you should measure how safe the guns are stored. Well, you can't measure that in a house with no guns, so that isn't really something that you can measure because you focused on the guns themselves. You need something that could happen in either group of houses that you could then measure.